Hello everyone. In this lecture, we'll discuss Newton's three laws of motion. So first of all, we'll discuss the first law of Newton's law of motion. The first law said that every body continues in its state of its rest or of uniform motion in a straight line except in so far as it is compelled by an external force to change the state. So in short, we can say that every material we can say that every material or object preserves own state its own state unless it is compelled by an external force, unless it is compelled by an external force. Sometimes it is also calls at law of inertia. Sometimes it is called as law of inertia. So let us take an example. If suppose there is a marble, which is at its rest position, so no motion is preserved in this marble. So unless we compile any external force or any external energy, the marble will remain rest for its whole lifetime. If we compel any force, like if we pushed that marble, pushed that marble, that will travels in that path. So let us consider that the path is friction free. So there is no friction. So when we pushed the marble will be in at motion position, or you can say that uniform motion position. So the marble, if I pushed the marble, or if I compel an external force to that marble, the marble will move at an uniform speed or uniform motion, and it will go in a straight line unless a force is applied to stop this marble. So this is known as first law, or Newton's first law of motion. So it is also known as law of inertia. It actually gives us the theory, or it gives us the concept of inertia. So now coming to the second one. The second one says that the rate of change of momentum of a body is proportional to the impressed force, and it takes place in the direction of the straight line in which the force acts. That means, suppose there is an object, I impel some force, or I pushed the marble, so I applied some forces in that marble. Suppose the mass of the marble is m, and when it is at at a position, so suppose it is a position, the marble has this velocity v1, velocity of v1, and when I applied the force of the when I applied any force of that marble, the marble will move on. That says the marble will move the direction of the straight line in which the force acts. If I act the force in the right side of that marble, the marble will move in the straight line of this path in that manner, and it will after imposed any force, the marble will have the velocity of v2. So this is its initial velocity, and this is its velocity after forcing after applying a force. So we know momentum means velocity into mass. The product of velocity and mass is known as momentum p. So what is the meaning of the rate of change of momentum? The rate of change of momentum is how long I applied the force. If I say that I applied the force for t second, I applied the force for t second, so the rate of change of momentum will be d of p by dt, d of p by dt. And it says that the rate of change of momentum is actually proportional to the force. It's actually proportional to the force. So from that we can write for p we can write mv, because when instead of momentum we'll write mass and velocity of product of mass and velocity. So we can also write this at that manner, like f is proportional to dm by dt plus not like that, m into dm by dt plus v into, oh sorry, give me some time, I actually mistake. The we will use the, as it is a differential formula of t, so we will use the formula of uv. So it says that for differentiate of uv, it means we take u and differentiate the v, plus we take v and differentiate the u, du by dx is actually u. So by the help of this we will also apply this formula, uv formula in there. So I can write, if I take m, then I will do the dv by dt, and if I take v, I will differentiate dm by dt, the mass. In Newtonian physics, we thought that mass is constant. Mass is constant. Mass is constant. So in that case, to for this differentiation over time, we'll get 0, because we know that the differentiation of any constant value is equals to 0. So this whole term will be equals to 0. Hence, we will find out f is proportional to m into dv by dt. And the means of dv by dt is also the rate of change of velocity, which is known as acceleration. So we can write ma. And if I want to remove this proportional sign, I will write this thing as f equals to k into ma, where k is an constant value, constant value, while k is a constant value, or we can say that it is a proportionally constant. So from this equation, if I put k equals to 1, I will get f equals to ma, and hence it gives us an equation or a formula to calculate force. So if I want to calculate force to any object, if I know the mass of this object and the acceleration of that object, I can easily find out what is the force of applied to that object or to that particle. So Newton's second law uh, gives us the actually how we can find out the force of any object. So this is an important law in our physics, because after impiling this law, we get how we can find out any force applied any object or any motion or any particle, sorry. So this is known as second law of motion. And in that case, the unit of force is newton. We have to remember the unit of force is newton. So this is the second law of motion. Now coming to the third law of motion. The third law of motion says that to every action there is an equal and opposite reaction. We actually heard this phrase over and over time, and this is the actual third law of motion. Newton's third law of motion, which says that to every action there is an equal and opposite reaction. So what that means? That means suppose suppose I applied a force in a wall. This is a wall. I applied a force in that wall. So when I applied force, suppose I punch that wall. When I punch that wall, I feel some pain in my hand. So from where this pain come? This is the question. Why this pain come? So why is this pain come? What is the why from where the pain is like created? This is the question. So when we are going to find out this question, we can find that when we push F force to that wall, the this wall will also gives us an equal force like reacted force R into our hands. For this reacted force, I feel some pain in my hand. So this is the third law of motion. So if I put F force in some particle or object, the particle or object will also give me an R force which is equal but opposite, which is equal but opposite. This is the third law of motion. So in third law of motion we will have different examples in third law of motion in our daily life. Like if I want to find out how firing a bullet from a gun, firing a bullet from a gun. So when suppose this is the gun, so when we triggered this gun, a bullet will go from this end to from this end, and the gun will also move back towards our shoulder. So why this happened? Because it impels some force in that direction, and the force will gives us and reacted force in that direction. So that's why we feel some pain in our shoulder. So another common example of Newton's third law is walking. Walking. Suppose when we walk, so suppose this is our leg. So this is our leg. When we walk, we actually apply some forces in that manner, in that direction. Suppose this is our leg. So this is the ground, and when we walk in the ground, we will give some force in that trajectory, and the force will give us a reacted force equal and opposite direction. So that's why when this reacted force occurs, then the reacted force helps us to pull down our leg from the ground. In that manner, we walk through the ground, or through the like what should I say, through our life cycle. So this is an example of Newton's third law of motion. Now coming to the last part of our lecture, this is known as impulsive force and impulse force. So first of all, what is impulsive force? So impulsive force says that impulsive force force is a force is a force of of very high magnitude, of very high magnitude, for a very short time, for a very short time, and it is denoted as J. It is denoted as J. So what is this impulsive force says? Impulsive force is a force of very high magnitude, and it applies for a very short time. Very short time. That means, suppose take as an example of cricket. When a bowler release the ball, like this is a pacer, the pacer threw the ball towards the batsman, towards the batsman, and when the balls came, it came with very high, it came with a very high pace. So very high pace means very high magnitude, and when it touched the bat with that magnitude, with that very high magnitude, actually it applies for a very short time, like nanosecond, because it just touch the bat and the ball go through the direction the batsman uh, wanted to uh, wanted to throw the ball. So when this happen, the time is very short, like a nanosecond. So when these types of occurrence occurred, this is known as impulsive force. Impulsive force is actually it actually means force into times, but here's the catch: the force will be very high and the times will be very short. Force will be very high and the times will be very short. So this is known as impulsive force, or we can say that impulse of a force. So that's all for today's video. In our next lecture, we will discuss the conservation of momentum, and about the friction. Please like this video and do subscribe to our channel. Thank you.